Hi everyone, welcome to my YouTube channel, and in today's video I'm going to tell you everything you need to know about nuclear fusion. But before I start, make sure you subscribe to this channel and don't forget to press the bell icon so you never miss any updates. First of all, let's understand the meaning of the word nuclear fusion. When we say the word fusion, we mean specifically nuclear fusion. In simple terms, it means the nucleus of an atom. Originally, the word nucleus meant the kernel in the centre of a nut. It is also the centre of everything small. Small things have a nucleus and big things have a core. It's quite simple. Now we know what nuclear energy is. But what is fusion? Fusion is the combination of several things into one. The Sun is the Earth's central energy source, yet the planet only receives a tiny fraction of its energy, and the Sun is just an ordinary star. Many stars generate far more energy than the Sun. The root of each star's energy is nuclear fusion. With nuclear fusion, smaller atomic nuclei combine to form larger ones. This phenomenon usually occurs in the core of a star, but it did occur a little in the early universe. It can also occur in hydrogen bombs and nuclear reactors, anywhere in conditions similar to the core of a star. Now, you may be wondering what kind of things can be made. Well, that depends on what you combine. The Sun fuses hydrogen into helium, which is not surprising, since the Sun is mainly made of hydrogen. So is the ordinary matter of the universe. To be precise, however, when we say hydrogen, we're not talking about a molecule of hydrogen gas or a hydrogen atom. We are talking about a hydrogen nucleus. It is so hot in the Sun that hydrogen can no longer hold on to its electrons. The electrons and protons become free. It's just a bunch of electrons and protons moving around freely. We call it plasma. Is it like the stuff in your blood? Well, no, that's biology. This is physics. Different things. Anyway, these protons are still called ionized hydrogen, or H+. As you can imagine, this leads to all sorts of confusion. Keep in mind that for the rest of the video, whenever I refer to an element in the periodic table, I'm only talking about its nucleus. Okay, now the question arises like, why doesn't fusion happen everywhere? You can put neutral atoms together all day long, but atomic nuclei are charged, and smaller charges don't like to be close to each other. Whether it's giant uranium, medium iron, or tiny hydrogen, all nuclei carry positive charges, which repel other positive charges. This process is known as the Coulomb barrier, and it takes a powerful force to overcome it. Perhaps gravity. The Sun has plenty of it. It contains 99.8% of the mass of the solar system. A lot of mass means a lot of gravity. So the Sun, a giant cloud of mostly protons, uses its gravity to force those protons together. It looks like a Hulk smash. Another question arises though. Doesn't helium have neutrons? Well, it's confession time. While the idea of nuclear fusion is pretty simple, the actual processes are not, which is pretty typical of real life now that I think about it. Anyway, before we get into the details, there are a few things you should know. Firstly, during all nuclear reactions, energy, momentum, and charge are all conserved. Rest mass is not conserved, but it is a type of energy, so it is accounted for in this way. We will call it energy for the rest of the video. Secondly, neutrons can decay into protons whenever they want, because neutrons have more rest energy than protons. This does not happen often, otherwise there would be no neutrons, but it does happen. Thirdly, protons can decay into neutrons, but only with a little help. The extra rest energy has to come from somewhere. In general, kinetic energy is lost when they collide with another particle. Finally, remember that protons don't like to be together, but neutrons can help them stay together. At the top of the periodic table, the number of each is about equal, but as you go down the table, you need more neutrons than protons. Alright, we are now ready for nuclear reactions. Nuclear fusion reactions power the Sun and other stars. As we said before, hydrogen fusion turns 4 protons into a helium and some light. But some of this light comes from the annihilation of antimatter with electrons. There are also some neutrinos produced, because why not? This whole process can happen in many different ways. The proton-to-proton chain adds protons one by one, creating neutrons along the way through decay and releasing light and neutrinos that escape from the Sun. The CNO cycle releases the same light and neutrinos, but uses carbon, nitrogen and oxygen along the way to make helium. In either case, the Sun will eventually run out of hydrogen, forcing it to fuse the helium into carbon, which it does using the triple alpha process. If you're wondering, helium nuclei are sometimes called alpha particles, and it takes 3 to make a carbon, hence the name triple alpha. Even after you get the temperature right, a lot of things still have to happen in a certain way. If you smash 2 protons together and neither of them decays into a neutron, they both decay. If you explode 2 heliums together, the third one has to come quickly, otherwise the first 2 decay. If you want to make more giant nuclei, things get even more difficult. The bigger a core is, the more it wants to push the other cores away. Sometimes the core of a star is hot enough for this, but other times you have to sneak in a neutron and wait for it to decay into a proton. This is called neutron capture, and it can happen slowly or quickly. Making all the elements in the periodic table is more complex than it sounds, but we have a great source of clean energy if we can get it right. Nuclear fusion is still a long way off. There are still many obstacles to overcome, but if mankind succeeds in this feat, then it will most likely solve all energy problems. One big advantage: the energy generation would be almost clean. So, are you excited about the future of fusion energy? Let us know in the comments section below. If you like the video, don't forget to give it a thumbs up and share it with your friends. Don't forget to give us your thoughts and comments in the comments section below. You can also suggest what topics we cover in future videos. Finally, if you are not yet a subscriber to the channel, please subscribe. And if you want to see more videos like this one, hit the bell button so you will be notified every time I upload an interesting video. So, we'll see you in the next video. Bye for now.